students, welcome back to another wonderful section of this lovely tutorial class. Today I'm going to be taking you guys through a journey in mathematics, basically coordinate geometry. And for you, listen to this advice. The first thing you have to do for me now is to ensure you avoid anything called distraction, and also don't ever skip any part of our videos. Ensure you watch the video from the beginning to the end. Why are you doing this? In order to get everything we'll be doing in that class. Because if you are skipping the videos, you may not get the full understanding. And what we are trying to do here is not just to entertain you, it's to teach you that thing you are about to get in this video class. That's what we are trying to do in this place now. So if I were you, I will just sit down, watch this video without any distraction, and don't skip any part of this video. I won't do it. I won't skip any part of the video. Just watch it from the beginning to the end. Fix your eyes to us, and you can take your pen or something like a notebook, you write, take a calculator, then you just follow us as we are in this class now. Now, you know you are not subscribed to our channel, please try and do so as well. It will be very, very helpful. So the next thing now we have to do is to go to this topic properly, which is a coordinate geometry. You know, we have done equations of a straight line, and today I want to look at what I called angles between two lines. Angles between what? Between two lines. How to get the angles between two lines. Now, generally, the model or the formula is that tan of any angle between two lines, the tan of any angles between two lines must be equal to m2 minus m1 divided by m plus m2 m1. Now what is m2? m2 is the slope of the second line, m1 is the slope of the first one, then which is m2 slope of the second one, m1 slope of the first one. Now remember what we did in the last class. We said if two lines are perpendicular, they are graded, or the slope will be what? If you multiply it to equal to minus 1, if two lines are parallel, their slope or gradient m1 will be equal to m2. Those are still m, you are seeing only the slopes or the respective gradients. Now today I want to look at how to get the angle between two lines. How to get angle between what? Between two lines. Now the first question is to find the angle, define the acute angle between y is equal to this and y is equal to this. Acute, the acute angle between y is equal to 2x plus 6 and y is equal to 3x minus 2. How do you get the acute angle between those lines? Now I can just tell you, find the acute angle between two lines whose gradients are this and this. I'll just give you the gradients. You are also good to go with that. But this time now, the equations of the lines were given, but the gradient was not given. Now how do you get the gradient of a straight line? How do you get the gradient of a straight line? First now, solution. We are going to get the gradient of these two lines. And the first line is that y is equal to 2x plus 6. And how do you get this gradient? Now, to get the gradient, I showed you guys two ways in the last class. I showed you guys two ways. I said the first thing, you ensure you make y the subject of the formula. The next thing you do, you will take the coefficient of x, that will be the gradient. In the sense that you will just take y is equal to mx plus c. This is the equation of a straight line. This is the equation of a straight line. So this m is the gradient, while c is the intercept. This is y-intercept now. That's what I'm trying to say. So the coefficient of x is actually the gradient. So this 2 now will be the gradient, or our gradient will be equal to, you can also say is equal to 2. Gradient is equal to 2. Because the first one is equal to 2, which is the coefficient of x. Because the gradient is equal to dy over dx. This is that you differentiate this y with respect to x, so that will also give you gradient. And that will be equal to differentiate 2x, we will have 2. Differentiate 6 is 0, so the gradient will still be 2. So our m1 is 2. Then from the second line, y is equal to 3x minus 2. So what will be the gradient of the second line now? What will be the second line? We checked. Y is already the subject of the formula. So what we have to do, just keep the gradient of x is what? 3. That becomes the gradient. Or we can also say our m2 will be dy over dx. This will be our first line. This will be our second line. dy2 over dx. That is the y by the second equation of the second line, the respect to x. That is, we have to differentiate this one now. Respect to x, we're going to have differentiating 3x, we have 3. Differentiating 2, we have 0. That is 0. So the gradient will be what? Will be 3. So we now go to this formula that therefore we said tan of this angle is equal to the second gradient minus the first gradient over 1 plus the second gradient and the first gradient. The next thing we're going to do now will be, I say tan of this angle will be equal to, what is the second gradient? 3 minus 2 over 1 plus 3 times 2. That will give us 1 over 3 times 2 is what? That is 6 now. 1 plus 7. So that's going to give us the tan inverse of 1 over 8. Tan inverse of 1 over 8. Then that's going to give us I can't actually simplify it well. So tan theta will be equal to 1 over 8. So to find theta now, we have to explain that so that you follow. To find theta, what you just do, you take the arctan on this other side. If tan theta is equal to 1 over 8, theta will be equal to arctan, which is tan inverse of this other side, is 1 over what? 8. That's how to find theta now. So to find the arctan of 1 over 8, find the tan inverse of 1 over 8, the answer is going to be approximately 8.1, 8.130 or 8.1 degree. Can you say 8.13 degree? That will be the angle, acute angle between this line and this other line. That's how it is done. The first thing, find the slope of the first one. Second thing, find the gradient of the second line, and apply that formula to get the acute angle between those two lines. So let's look at the second one. Solution. So find the acute angle between y is equal to this. No, just y minus 3x minus 7 equal to 0. 3y minus 3 minus 8 equal to 0 as well. Find the acute angle between these lines. So the first one is y is equals to, that is y minus 3x minus 6 equal to 0. So how to get this slope? I told you there are two ways. So that you differentiate it, or you can differentiate by using implicit differentiation. Because this one has solved the formula. So use implicit differentiation to do that. You get the slope directly. Because so you just make y the solved the formula and also give you the slope, which will give you the question of s. So we want to make y solved the formula, we're going to have y equal to move away to the right side, and that is plus 3. If my solution comes to this line, become plus 3x. If my solution becomes plus 7. So if I ask now, what is the intercept of this line? The intercept is what? 7. But as what is the slope of this line? The slope would be, the slope of the first one now would be the coefficient of s, which is what? 3. That will be the slope. You can also differentiate to get the slope. That will also give you the answer. So for the second line, we have 3y minus x minus 8 is equal to 0. So making y equal to 3y is equal to, move into the other side, we have x plus 8. Then the next thing, we are going to divide everything by 3. Divide this one by 3 and divide everything here by 3. So this one will cancel this. Y will be equal to x over 3 plus 8 over 3. First one, what is the slope of this line? I'm going to write this. I'm going to say y is equal to 1 over 3x plus 8 over 3. I'm going to write it this way. Because the coefficient of s is 1 over 3x plus 8 over 3. So now we don't see the coefficient of s there. So if I ask now, what is the intercept of this line? The intercept of this line is 8 over 3. That is the intercept. But ask what is now the slope of this second line? The slope will be what? The coefficient of s. Since we have made y the slope of the formula, that will be 1 over 3. To get the slope again now, we can differentiate this one using implicit differentiation. Remember how to differentiate using implicit differentiation. You also say dy over ds will be minus dx. So if I differentiate with respect to x, differentiate this one, that is 0. Differentiate this one, that is minus 1. That's minus 1 over, differentiate this one, 0. Then over dy. Differentiate this one, that was 3. This one is over by 0. Bring that is 0. That will give us 1 over 3. Easy differentiation. Remember, minus ds over dy. From implicit differentiation, we say the y over ds equal to minus ds over dy. From implicit differentiation now, so you can also do it to get the answer. Or make y the solvent of the formula that will also give you the slope. So next, we will state that, therefore, we said tan theta will be equal to what? M2 minus M1 all over 1 plus M1, M2, M1. That will give us M2 is 1 over 3 minus M1. What is M1? M1 is 3 all over 1 plus 1 over 3 times 3. That will give us 1 over over 3 minus 3. What I do have? 1 over 3 minus 3. I just solve this with calculator. 1 over 3 minus 3. That's 3 minus 1 over 3. We're going to do this. And that'll give us 3. 3 times 3, that's 9 minus 1. That's 8 over. So this is going to give us minus 8 over 3. That's what we're going to have here. Minus 8 over 3. Then over. This we cancel this. 1 plus, that's 1 times 1. Because you don't have to be doing it this way, you can just do it directly from here. You can just say theta. From this place, you can just say theta is equal to the tan inverse of this other side. Inverse of m2 minus m1 all over 1 plus m2 m1. You just impute everything to your calculator. Just press arctan, press bracket, press division. Put m to here, put m1 here, 1 plus m1, m2 m1. Just close the bracket. Press an equal to. You have the answer directly from there. So you also get the answer from there. So let us solve this. So we will have that minus 8 over 3 divided by this one is plus, that is 2. That gives us minus 8 over 3. This times, take the value on the other side. You change up the times, take the value on this side. That's how to do division of fractions. 1 over 3, 2 now. 2 here 1, 2 here 4. So we will have minus 4 over 3. So that means tan theta actually. What I have tan theta here? Tan theta, I have tan theta here. Tan theta is equal to minus 4 over 3. Then what theta will now be the tan inverse of minus 4 over 3. And that gives us approximately 53.1. 53.1 degree. That's what we're going to have approximately. Now let's quickly look at how to get the gradients. Gradients between 2 points. We have how to get the gradients between 2 points. We have 2 points now to find their gradients. Then how to find the distance between 2 points, and how to also find the what's it called? The midpoint.
Alright, in case you don't know the meaning of these two symbols, they denote the magnitude of the expression you are having in this place, which is m2 minus m1 divided by 1 plus m2 m1 or m1 m2. So even though you are doing m1 minus m2, so you are taking the magnitude to get the acute angle, because this should not be negative for acute angle. Now to get the acute angle, you just take the magnitude of this. In case you have a negative value here, that's what I'm trying to say. In case you have a negative value here, you just take the magnitude of that negative, which is positive. Magnitude means the size only. Just forget about the signs and use only the positive value. If you have like minus 4 over 3 that we have in the last question, just do 4 over 3 and forget about the minus sign. If you have minus 3, do 3 and forget about the minus sign. That is mean of this magnitude that is here to get the acute angle, because you are looking for acute angle, not just anyhow angle. Thank you. So don't forget, these two symbol you are seeing here means the magnitude or the absolute value of this expression. And so even though you are not doing m1 minus m2 here, you still have the same thing, because you are taking just the absolute value, which is the magnitude. Just forget about the signs, take the size only. Yeah, so let's move to the next agenda now.
Now, to get the gradient of a line joining with 2 points, how to get the gradient particular straight line joining 2 points. Now, the first question we're having here is for you to know this model. Now, n, I already showed you from the equation of a straight line, this n denotes the gradient. This n denotes the gradient. Then you have y2 minus y1 all over s2 minus s1. Now, the slope of a line joining 2 points, the points are s1, y1 and s2, y2, y2. Now to get the slope of to get the gradient of the line joining this point and this point, the gradient will be equal to y2 minus y1 divided by s2 minus s1. That's how to get the gradient of that line joining this point and this point. Let's say we have a straight line, you know 2 points, it's line joining this point and this point. Then this one is s1, y1, this other point is S2, comma Y2. If I want to get the gradient of this line between these 2 points now, from these 2 points, using these 2 points is known. I just follow this equation. The gradient will be equal to Y2 minus Y1 divided by S2 minus what? Minus X1. From here now, let's go and see what we're going to have. The question is, find the gradient of the line joining the points. Number 1 is 3, 6 and 2, 7. Number 2 is 3, minus 7 and 2, minus 4. Number 3 is a, squared and b, b squared. That is the question. So how are we going to do this now? Now let's say for the first question, the first one, number one question, what are we going to have here now? What are we going to have? Now the point you're looking at is 3, 6 and 2, 7. That is the point. From here, our what's our x1? Our x1 means this one is x, y, s1. This is the first point. So this is the s1, then which is equal to 3. Then our y1 is this first point for y, is equal to 6. Then our f2 is equal to the second point, the first one there, is equal to 2. And our y2 is equal to what? 7. So these are s1, y1, s2, y2. Please follow it in that order. Now we know that the gradient of the line during these 2 points will be y2 minus y1 all over s2 minus what? x1. So therefore we're going to have y2 is what? What is y2? y2 is 7 minus y1 is what? What is y1? 6 all over x2 is what? 2 minus s1 is what? 3. So I'll give us 1 over minus 1. Right? That's 1 over minus 1. So that'll give us minus 1. That's the gradient of the line that's doing this point and this point. The gradient is minus 1. Then the second question is we'll have 3, minus 7 and we have 2, minus 4. I hope we're able to get this. Just impute that as well. So the gradient will be equal to what will be the gradient for this now? y2 minus y1. Now for this one, this one is y2. What is y2 here? This is our y2, this one is y2. This one is x2. This one is y1. This one is x1. So just go, our y2 is minus 4. Minus 4 minus y1 is minus 7. Minus 7 over x2. x2 is what? 2. Minus s1 is what? 3. S1 is 3. So therefore we are going to have our gradients to be equal to, the gradient will be equal to what? Minus 4, minus as minus, plus 7 over 2 minus 3 is what? Minus 1. That will give us, minus 1 plus 7 will be plus 3. That's why I'm going to have over minus 1. The gradient of this one will be minus 3. That will be the gradient of the line joining these points and this point. Now let's find the gradient of the line joining this point and this point. The gradient will be, the third one, our first one is a, squared, and the second one is what? b, b squared. So our x1 is a, our s2 is b, our y1 is a squared, and our y2 is what? B squared. This is y1, y2, s2, y1, s1. So therefore, apply this formula, our m will be equal to y2 minus y1, y2 minus y1, y2 minus y1, that is b squared minus a squared, all over s2 minus s1, that is b minus a. So this is going to give us our m will now be equal to, now from difference of two squares, look at it, b squared minus a squared is the same thing as, remember difference of two squares, we have a number square minus another number square. That's what we call difference between two squares. So this in mathematics is equivalent to b minus a times b plus a. B plus e. This and this are equivalent. If I want to expand this, I'm going to have this. It's not for plus, so for plus will work. I want to factorize this, I'm going to have this. This is called difference of two squares. It will be b minus a times b plus a. That will be the answer. So we're going to have the numerator. We're going to have, using difference of two squares, we're going to have b minus a, then b plus a over b minus a. So this will go with this, plus A. You can also say A plus B. These and these are both correct. They are very, very, very correct. So this is how we find gradients or slope gradients of a line joining 2 points. So last now, to find the gradients of the line, joining the points 1, 1 and 5, 6. Find the gradients of the line joining the points 1, 1 and 5, 6. What will be the gradients? So can you do that? You try to do it. The gradient is going to be 5 over 4. That will be the gradient. 5 over 4. That's what we're going to have as the gradient. So you try and do that to see what you can have. Thank you. Let's move to now how to get the different distance between 2 points. Distance between 2 points. That's the next one I'm going to look at now. Distance between 2 points. Let's look at distance between 2. Now, distance between 2 points. How do we get distance between 2 points in which they are whose coordinates are known? So, if you know the coordinate of points, and you want to get the distance between those points, and if there are 2 points, the model follows that the distance between points, A, can be coordinate of A, S1, Y1, and B, S2, Y2 is AB. That is the distance between A to B. Move from A to B, we have equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That is the distance between 2 points. If you don't have x and y coordinates, if you like to play points. But if you have 3 coordinates, let's say x, y, z, and which point A is s1, y1, z1, and point B is s2, y2, z2. The distance between A and B will not be the square root of s2 minus s1 squared plus y2 minus y1 squared plus z2 minus z1 squared. That's all. As simple as that. So you just try and get this model. You already know the meaning of y1, s1, and all that. But this question, if I ask what is y2 here? Y2 is the second one, the y part of it. Remember this s1 and y. This one is s1, y, z. S1, y, z. The second one is 2, the first one is 1. Take note of that. So look at the solution to this. Find the distance between the points 3, 7 and 6, 11, 0, 0 and minus 4, minus 4, 3, 1 and minus 1, minus 3, minus 1, 1, 2 and 1, minus 2, what? 1. So these are 4 questions in one. We're going to look at them now. Solution. Now for the first one, the points are 3, 7 and remember this is handle, maybe this hand, this is going to be this hand, and 6, 11. So what's our x1 there? Our x1 is 3, is first one. Y1 is what? This first y, which is 7. This is x1 y. The x2 is the second one, which is 6. Y2 is the second one, which is 11. The next step we're going to apply, because since we have just 2 coordinates here, 2 points, just 2 coordinates s and y. We will have our distance, which is d, will be equal to the square root of s2 minus s1 squared minus y2 minus y1 squared. That will give us the square root of, what is x2? Our x2 is 6. That is 6 minus 3 squared plus what about y2? 11 minus 7 squared. That is going to give us something very nice. And the square root of 6 minus 3, that is 3 squared, plus 11 minus 7, 4 squared. That's going to give us 9, that's root 9 plus 16, and go root 25. This will give us something very nice, which is 5. The distance between this point and this is 25. That is 5. That is the distance between them. 5. Then the second one, number 2. For number 2, the distance between point 0, 0 and the distance and point minus 4 or minus 4. So the distance between these 2 points now. Let's look at it to see what we have. And the distance will be equal to the square root of x2. Square root of S2. What's S2 and S2? Minus 4. Second one. Minus x1. X1 is what? 0. X1 is 0. Then plus square it. Plus y2. Y2 is minus 4. Minus y1 is still 0. Square it. So this will give us the square root of, that's minus 4, everything squared, plus minus 4, everything squared. It will give us minus 4 squared. It's going to give us plus 16. So it's going to give us minus squared is plus. Then plus this one squared is also give us 16. So that's what we have. Would you give us 32? That's what we have. 32. Now what's root 32? Root 32 is something like 16 times 2 will give us 32. So that is 4 root 2. Actually, some reason later I don't have 4 root 2, which is root 16 times root 2. It was 4 root 2. That's what I don't have there. Then the third one, the distance between the points 3 minus 1, 3 and minus 1, minus 3. It's not between these points. Let's see what I'm going to have. So I'm going to have something very nice. That is, the distance now will be equal to the square root of x2 minus s1. This is s2 here. S2 minus x1 squared plus y2 minus y1 squared. This is going to give us minus 1 minus 1, that's minus 2 squared plus minus 3 minus 3, that's minus 6 squared. So this one is going to give us something very nice. Minus 2 squared, where's that one? Minus 2 squared is 60, that is 4. That is plus 4. Minus 6 squared will be 36. You square minus will become plus. So this is going to give us the square root of 4 plus 36, that is 40. That is 40. That is 40. And 4 times 10. 4 times 10 is 40. Can you remember? 5 times 4, 5 times 8 is 40. That's not valid. Then so we can call this one. I think this one is 2 root 10. I think this one is 2 root 10. Call it 2 root 10. 2 root 10. Yeah, I call it 2 root 10 because that is the best way we can simplify that. Because which is 4 times 10, that is 4 times root 10. That was 2 root 10. Then the last one is points minus 1, 1, minus 1, 1, 2, and points 1, minus 2, 1. So this is going to give us something very nice. The distance between these points will now be the square root of, I don't know if you can remember, s2 minus s1, y2 minus y1, z2 minus z1. S my y comma z, s1 comma z, that's going to give us s2, 1 minus s1 plus y2 minus y1 plus z2 minus z1. So it will give us the square root of 1 minus is plus. And 1 plus 1, that is 2 squared, plus minus, that's minus 2, that's minus 3 squared, plus 1 minus 2, that's minus 1 squared. So this one is going to give us something very nice. That will be giving us something very nice. That is 4 plus minus we change to square minus we change to plus, that's 9. Plus square minus change to plus, that's 1. That's the square root of 4 plus 1. Okay, 4 plus 9, that is already 13 plus 1, that is 14. That's really 14. So 4 times something cannot give us 14. 9 times something cannot give us 14. So 14, let us read that root 14. Read that root 14. So that's why I go down root 14. Root 14. So this is how we roll in when we're looking at distance between 2 points. So the next one I'm going to do now will be the last class for today, or the next one I'm going to now is the midpoint of the line segment. The midpoint of the line. How do you get the midpoint of the line? And how it is still very simple. What you have to do just to try your best, follow us, and you're already going to go. The midpoint of the line segment. So let's go into that to see the next thing we will have. So thank you as we go into the midpoint of the line segment. Alright, midpoint of of a line segment. Midpoint line segment. Now, the coordinates of the midpoint of a line that join 2 points, let's say x1, y1, and s2, and y2. The coordinate will be, for x coordinate will be x1 plus x2 divided by 2. The y coordinate will be y2 plus y1 divided by 2. That's all. It's a very simple thing. The example now is find the coordinate of the midpoint of the following. Midpoint following. This and this. What is the midpoint between those 2 points? This and this. That will be what is the midpoint between those 2 points. That is 2,7 and 6,9. What is the midpoint here? Minus 1, 2 and 3,4. What is the midpoint? 2p, q and p, 2q. What is the midpoint? Minus 1, 2 and 3, minus 4. What is the midpoint? Remember, we have 2 points. S1, Y1, and Y2, S2, S2, Y2. The midpoint of those 2 points is X1 plus S2. Or you can just say, so I will be right. It's still the same thing, because plus is commutative. Because in Y, S2 plus S1 divided by 2, then Y2 plus Y1 divided by 2. Then I use Y1 first, Y2. Because plus is commutative, nothing will change. So let's go into this solution. Solution into this question now. Solution this problem. So let's see what we're going to have. So on the first point is, for the question 1, we have 2,7 and 6,9. That's what we're having here. We have 2,7 and 6,9. So for x coordinate, we have x1, that is x2 plus x1 over 2. So the y coordinate, we have y2 plus y1 over 2. So what do we do for x coordinate now? What is x2 here? What's our x2 here? Our x2 is equals to 6. Is this? Y2 is equals to 9. X1 is equals to 2. Y1 is equals to what? 7. So we put into this formula now. Let's go ahead and have. Let's go ahead and have. Our x is equal to what? 6 plus s1 is equal to what? 2 over 2. What are we going to have here? We're going to have something very nice. That's 8 over 2. That's 4. Then for our y will be y2. Y2 is 9 plus y1 is 7. Y plus 7 over 2. That's going to give us 16 over 2. Will give us 8. So the coordinates of this now will be, for the first point now, the midpoint. The midpoint now, the midpoint will be x, that is s, y. S, y. That will be what's our s here? Our s was 4, our y was what? 8. So this will be the midpoint of this and this. That's the midpoint. So for the second one, the number 2, we have minus 1, 2 and 4, that's 3,4 and 3,4. That's what I have here. 3,4. So the midpoint now, the midpoint will be x, what? Y. So what's our x? What's our x? Remember, x is s2 plus s1 over 2. What's s2 here? What is s2? s2 3 plus s1 is what? Minus 1 over 2. That gives us 3 minus 1 over 2. Plus times minus is minus. That's 2 over 2. That's 1. Then, what about y? Y will be, our y is y2 plus y1 over 2. What's y2 is 4? 4 plus 2 plus y1 is 2 over 2. That's 6 over 2. That's going to give us 3. So the midpoint now, the midpoint will now be, s, y. That is what? 1, 2. This will be the midpoint of this and this. So let's go to the third one. Go to the third one. That is midpoint between 2.2p and q and p, 2q. Now what is the midpoint between these 2 points? So the midpoint will be for x. For x now we're going to have s2 by p plus s1 2p over 2. That goes p plus 2p was now. That is 3p over 2. So nothing can go into that. Then our y will be, y is y2. Y2 is 2q plus y1. Y1 is this, is q over 2. That's 2q plus q, that is 3q over 2. So the midpoint now, the midpoint will be equal to s comma y. What is x? 3p over 2 comma y. What is y? 3q over 2. That's what we have. So this will be the midpoint. For the last one, you can do this yourself. Okay, let me just do it. The point is what? 3 comma 4 and minus 1 comma 2. Right, where's the midpoint? For x, remember for s is what? For s will be s2. S2 is 4. And s2 is 4. Where is it? Okay. S. Okay. Let's not have this equal. We have this and this for our number 4. Sorry about that. For number 4 is minus 1 comma 2 and 3 comma minus 4. That's not our big mistake. So what's our S2? Our S2 is 3 plus minus 1 then over 2. That is 3 plus minus, that's minus 3 minus 1 over 2. That's 1. Then our Y will be this plus this, that is this one and this one and this. So we're going to have 2, that's minus 4 plus 2 over 2. That is going to give us minus 1 plus 2, that's minus 2 over 2. That's minus 1. Because minus 1 plus 2 is minus 2. Then remember that's minus 1. So the midpoint now, the midpoint will be s comma y. That's 1 comma what? Minus 1. If you go and write minus 1 comma 1, you are wrong. Yeah? But put in the way of s comma y. The first one is s, the second one is y, the third one is z. So we are going to halt this class in this place now. Then next time we're going to continue from here. So please ensure you follow our classroom. Ensure you don't skip any part of the video. In case there's anything you don't get, you are free to go back and watch this video over and over again. You are free to watch it. But everywhere is calm. You want to watch it again. Keep on watching it for revision purpose. You know, in mathematics you must revise. This is revision class. When you just teach revision, every day you can be revising it every day. The more you revise it, the more you know it. So you watch it and be filled. Thank you. See you guys in our next class. God bless you. Thank you.